we are going to explain about a project titled Minimizing Cloud Energy Usage by Applying OEMACS and Flower Pollen Algorithm. So now coming to the introduction part. In this context, the integration of OEMACS and the Flower Pollen algorithm represents a novel and the promising approach to address the challenge of minimizing cloud energy usage. By combining the intelligent resource allocation capabilities of OEMACS with the adaptive and parallel search capabilities of the Flower Pollen algorithm, cloud providers can achieve significant energy savings without compromising the performance and reliability of their services. On the other hand, the Flower Pollen algorithm draws inspiration from the natural foraging behavior of bees and pollen grains. This bio-inspired algorithm mimics the collection intelligence and decentralized decision-making of bees as they search for food sources. So now coming to the objective part for this project is to pave the way for a greener and more sustainable cloud ecosystem. By embracing advanced optimization techniques and nature-inspired algorithms, cloud providers can lead the charge in minimizing energy usage and promoting environmentally responsible practices within the technology industry. Additionally, the successful application of OEMACS and the Flower Pollen algorithm can serve as a model for other energy-intensive sectors, inspiring the adoption of innovative approaches to energy management and conservation on a broader scale. On the other hand, the Flower Pollen algorithm brings a bio-inspired perspective to the problem, mimicking the foraging behavior of bees and pollen grains. This algorithm explores multiple potential solutions simultaneously, adaptively refining the search process to find the most energy-efficient configurations. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirement, first operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. So now coming to the methodology part, first upload cloud dataset. The first step in the process is to upload the cloud dataset, which contains relevant information about the cloud infrastructure, including the virtual machines, workloads, resource demands, and energy consumption data. Second, dataset initialization. Once the cloud dataset is uploaded, it needs to be initialized for further processing. This involves organizing and preparing the data in a format suitable for the optimization algorithms. This initialization step ensures that the algorithms can access and utilize the necessary information effectively. Third, run ACO algorithm. Here ACO stands for Ant-Ohlone optimization. Algorithm is one of the optimization techniques used to minimize cloud energy usage. Inspired by the foraging behaviors of ants, ACO simulates the exploration of paths and identifies the most energy efficient configurations for virtual machine placement and workload distribution. By running the ACO algorithm on the initialized cloud dataset, the system can identify promising solutions to reduce energy consumption. Fourth, run OEMACS algorithm. Here OEMACS stands for Optimization Energy Minimization Algorithm for Cloud Systems, is another optimization algorithm employed to minimize cloud energy usage. OEMACS intelligently manages the allocation of resources such as CPU, memory, and storage to optimize energy efficiency without compromising quality of service. By running the OEMACS algorithm on the cloud dataset, the system can dynamically adjust resource allocation and workload distribution to achieve maximum energy savings. Fifth, run flower pollination algorithm. The flower pollination algorithm is a bio-inspired optimization technique that mimics the pollination behavior of flowers. This algorithm explores multiple potential solutions in parallel, allowing for a more efficient and adaptive search process. By applying the flower pollination algorithm to the cloud dataset, the system can efficiently search an optimal configuration and resource allocations to minimize energy usage. Sixth, comparison graph. After running the ACO, OEMACS, and flower pollination algorithms on the cloud dataset, the next step is to generate a comparison graph. This graph visually illustrates the energy consumption results obtained by each algorithm. It allows for a clear comparison of the energy saving capabilities of each technique and helps identify the most effective algorithm in achieving the objective of minimizing cloud energy usage. So now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder named as dataset. In this we are containing some folders over here. And in all these folders we are again containing some folders over here. And in this we are containing some data set over here, that is negative, positive, zero, strong positive and strong negative. And so here this is the main Python file which is containing the Python script in it. And here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. Now click on upload cloud dataset button to upload the dataset for getting the output. So here I am selecting this dataset folder and now click on select folder to upload the dataset. So here on this screen you can see that the dataset has been loaded over here, which contains resource details, and we are using same dataset given by students. And so now click on dataset initialization button to read all resource and then initialize them. So here you can see that total 8 resources with different sizes are initialized. And now click on run ACO algorithm button to allocate requests to ACO optimized resource. So here on this screen we are generating 500 dummy requests and ACO assigning each request to minimum or underutilized load resources, and scrolling down above screen to see ACO energy consumption and time. We can see total execution time and energy consumed by ACO to handle all 500 records. And now click on run OEMACS algorithm button to choose optimized resource and then calculate time and energy. So now on this screen we can see OEMACS assign requests to different resource and then scrolling down above screen to get time and energy. So now on this screen we can see time and energy taken by OEMACS, which is lesser than ACO. And so now click on run flower pollination algorithm button to choose optimized resource using FPA. So here on this screen we can see FPA assign each request to different optimized resource, and now scrolling down to see FAP time and energy consumption. So now scrolling down you can see the time and optimization consumption. So here you can see that FAP time energy consumption over here. And now click on comparison graph button to get the graph. So here on this screen you can see that x-axis represents algorithm names and here y-axis represents execution time and energy consumption. In this graph, blue line represents energy consumption and orange line represents execution time. And in all three algorithms, FPA took less energy and execution time. So now coming back to the conclusion part. In conclusion, minimizing cloud energy usage through the application of OEMACS and the flower pollen algorithm not only benefits cloud providers and users, but also contributes to a more sustainable and eco-friendly technology industry. By striving more for energy efficiency and embracing innovative solutions, the cloud ecosystem can play a pivotal role in driving positive environmental change while continuing to meet the demands of a digitally driven world. As data centers and cloud infrastructures are known to consume vast amounts of energy, adopting energy minimization strategies is essential for contributing to global efforts to combat climate change and promote sustainability. Moreover, minimizing cloud energy usage through OEMACS and the flower pollen algorithms bring economic advantages to cloud providers.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.